Welcome everybody, we've been given this question. Let P be the image of a point 317 with respect to the plane x negative y positive z equal to 3. So the point 317 and P is the image of this particular point, which is actually obtained via the reflection through the plane x negative y positive z equal to 3. Now we are asked to find the equation of another plane passing through this point P, and it contains a straight line. And the equation of the line is given as x over 1 y over 2 is equal to z over 1. So the main objective is to find the equation of this particular plane. So we have to move along, or I should say the line of action for us is, foremost we have to find the point P. This is our first objective. Our second objective is to find the equation of the plane that passes through P. Okay, so once we are set with these two objectives, then the solution is complete. Now, having mentioned you this, let me start off. Foremost, this is the solution. Our first action is to find the equation, or I would say to find the point. So let me state that here. To find the point P, we will use the following formula. So what is that formula? Formula is x negative x1 over a is equal to y negative y1 over b is equal to z negative z1 over c is equal to negative 2 times ax1 positive by1 positive cz1 positive d divided by a squared positive b squared positive c squared. Okay, now we need to get the value of a, b, c. Right, now to find the point P, P is actually received or obtained because of the reflection of this particular point through via the plane x negative y positive z equal to 3. So we need to get a from this x negative y positive z equal to 3. A, B, C would be obtained from here, also D. So A is 1, B is negative 1, C is 1, and D is 3. Okay, so we have to obtain, in this case to obtain D, D will actually be negative 3 because D will have to come on this side. Okay, so A is 1, B is negative 1, C is 1, and the value of D is negative 3. Now having got this, we have to get our x1, which is the point 3, y1 is 1, and z1 is 7. So you substitute these points here. X negative 3 divided by 1 is equal to y negative 1 divided by negative 1 is equal to z negative 7 divided by 1 is equal to negative 2 times a is 1, x1 is 3, b is negative 1, y1 is 1, and c is 1, and z is 7, and d is negative 3 divided by 1 squared plus negative 1 squared plus 1 squared. So positive negative goes off. This will give me 6, and you have 2 there, and 1 positive 1 positive 1. This is going to be 3. 3 divides 6 2 times, so you get a negative 4 there. So over here you have x negative 3 divided by 1 is equal to negative 4. This means x is equal to positive 3 negative 4, x is equal to negative 1. So that's the first coordinate. And similarly, y negative 1 over 1 is equal to negative 4. Y negative 1 is equal to 4. This means y is equal to 4 positive 1, which means y is equal to 5. So that's the second coordinate. So the next one is z negative 7 over 1 is equal to negative 4. Z negative 7 is negative 4. Z is equal to 7 negative 4, which means z is equal to 3. That's the third coordinate. So therefore the point P is going to be negative 1 5 3. Okay, now we need to get the equation of the plane. So equation of the plane passing through P of negative 1 5 3 is given by, so this is going to be a times of x negative 1, so it's going to be positive 1, b times of y negative 5, and c times of z negative 3 is equal to 0. This is the equation of the plane. Now what we have to do is the plane contains the line, x over 1 is equal to y over 2 is equal to z over 1. Okay, so what I wish to do is I can club these two. X over 1 is equal to z over 1, which means z is equal to x, and x over 1 is equal to y over 2, which means y is equal to 2 times x. So if I were to take this as sum 2 can be rewritten as a times of x positive 1 positive b times of 2x negative 5 positive c times of x negative 3 is equal to 0. Now write the system, distribute ABC, so you get ax positive 2bx positive cx. Okay, that is one system. The next system is a negative 5 times b negative 3 times c is equal to 0. So if I were to take the coefficient of x, so in this case what I'll do, I'll take the coefficient of x. Consider the coefficients of x. So that is going to be a positive, 2b positive, c is equal to 0, and just the constant term, a negative 5b negative 3c is equal to 0. So we will solve these two systems. Okay, so I take this as sum 4 and 5. Solve 4 and 5 to get a, b and c. So that's the objective. So clearly I change the sign. So it's going to be I can add them, a positive, 2b positive, c is equal to 0. I change the sign, a negative 5b negative 3c is equal to 0. So negative is your positive, negative is your positive, so a gets cancelled, so you get 7b positive 4c is equal to 0. Okay, so this means 7b is equal to negative 4c, and this means b over 4 is equal to negative c over 7. So this is what you got. So now you can actually get rid of use the same system and get rid of say c Okay, so 4 multiplied with 3 is added with 5 multiplied with 1. Okay, so this is 4 multiplied with 3, so that's going to be 3a plus 3b, 3a plus 6b plus 3c is equal to 0, and then with 1, right, so it's going to be a negative 5b negative 3c is equal to 0. So you add, if you were to add these two things together, cc goes off, so this is 4a and positive b is equal to 0. So from here 4a is equal to negative b, so a is equal to negative b over 4. This is what you got, so this is a over 1. Now actually you see here, from here, what is this? This means negative b over 4 is equal to c over 7, right? Isn't it? So I can equate this to c over 7. So this means the required equation of the plane is x negative 4y positive 7 times z is equal to 0. Okay, so this is the solution for this question. Please like, share and subscribe. Thank you.